Okay, good morning, everybody. This is Justin from Data Migrators. We're just going to, since we're the first session of the day, of the virtual day, we're just going to make sure that the audio is working fine. So excellent, let's go for it. Okay, so I'm going to kick this off just quickly to get us going. We are here today to talk about the solution to getting you to new versions of DataStage from older versions. And this is obviously something that has been had a bit of a fraught history, but there is a new offering here. It's offered in collaboration with the Data and AI labs, and we're also joined by Elvis Gomba, who is the worldwide principal for that group. And what we're looking to do here is basically massively accelerate and reduce the cost of doing that exercise. So we're going to go through some background, and then we're going to show you some actual working software to give you just a quick taster of the experience that you'll go through if you go on this journey with us and IBM. Just moving to the next slide. Firstly, let's talk about the things that usually get in the way of upgrades and how we treat them. So first of the common anxieties are that people assume that the effort is going to be huge because it's difficult to size. How do you take some kind of empirical data and apply that to the number of jobs or number of projects or number of function points or whatever other aspects you might want to apply to your particular DataStage code base? The offering here uses a auto analysis tool that you'll see later on at no charge to essentially size the estimated effort around doing the upgrade. The next thing is we could come up with a number of person days or weeks or months, but where do you start? Where is the most important to least important areas of your code base? How are we going to treat those in the order that matter? Again, you could handcraft a backlog or a schedule. What we do is, in fact, as a byproduct of the auto analysis, we auto-generate a backlog for you and load that into one of a number of popular work item management tools. Today, you're going to see that in Atlassian Jira. The big eater of time here is, of course, the effort to actually move from the old version to the new version. And most, again, expect this to be a manual effort. In fact, what we do is we massively accelerate that through a high degree of automation. We essentially get you from the old version to the new version, from the old system to the new environment in a pretty much entirely automated fashion. Getting you ready for integration testing, and in fact also automating aspects of integration and end-to-end testing as well. The elephant in the room with upgrading is that you need to prove that your code has not regressed, and in many cases organizations have not got the existing test coverage to easily and without an awful lot of effort show the regression testing coverage necessary to satisfy audit teams or CAB teams and so on that you're ready to go live in the new platform. We understand this. It's just it's a byproduct of the fact that testing ETL solutions is tricky, and certainly at the unit level, it's often something that's honoured in the breach. We have, as part of the platform that underpins this offering, a unit auto creation capability and also a synthetic data creation or fabrication tool that feeds that. And we can run those unit tests in bulk as well for regression purposes. Internally, again, upgrades are a little different from what most BAU DataStage teams are used to working towards. It requires a slightly different approach to the work and experience around that. It's not usually sitting there in-house. Importantly, the Data and AI learning group, or the former UGNI Cloud Lab services, group has the consulting expertise and background to take you through that process and to optimize it. A little bit controversial, but what do you get out of this whole effort beyond just a new information server version? Well, apart from the fact that the new versions of information server, and particularly 11.7.1 just recently released, are astonishing in terms of the advance in capability. The other aspect is that you go through an end-to-end DevOps experience with information server, and that's not something that many teams have actually got running today in their BAU practice, or in fact even approached. You see Git source code control, you see automated testing, you see automated release management, automated delivery. You experience that and get to understand the value of that and what it does to alleviate the anxieties around moving code from one environment to another, and of course through the quality assurance process to go live. One of the things that the last things I want to cover is that the other big impediment to people upgrading is this idea that in order to be able to do an upgrade, you need to snapshot at a point in time the code in the legacy environment, or soon to be a legacy environment. It could be 8.5, it could be 9.1, it could be one of the 10 series. But you have to snapshot that and then essentially slow down change in the old environment. Now, that old environment is being used to deliver BAU value. There's going to be issues, there's going to be bugs, there's going to be new enhancements people want to do while you're going through your upgrade assurance process. And those guys need to slow down what they're doing, like they need a hole in the head. So the idea should be that we should reduce or eliminate that need to suppress change, and obviously end up with a long periods of outages or code freezes in the legacy environment in order to go live. We treat these by using the automation that's built into Metal CI to sync changes automatically from the legacy, the ongoing active legacy environment, into the target environment, to your 11.7.1 environment, for example. As those changes are made, it takes very little effort to make that automated pipeline kickoff. You're going to see that today. And that means that you don't have to sit in this extended code chill, and you certainly don't need to sit there waiting weeks or even days to go live once you have something that is passing all of your quality assurance measures in the target environment. We, as data migrators, are the creators of Metal CI. We're based here in Melbourne, Australia. We do have customers all around the world and service them well, and obviously very excited to be in the partnership with IBM. The offering components, just quickly summarize those. It's a combination of Data and AI Cloud Labs and Metal CI technology. This gives you a base offering which includes the Metal CI subscription for as long as the project runs, the installation and integration of Metal CI with your existing environment and your target environment, the automation processes I just talked about, the upgrading, the testing support necessary to get you to the point where you can either move into deeper batch level testing or in fact even go live. There are optional add-ons here. There is enablement services if you wish to take the DevOps practices that you're experiencing through this upgrade and adopt it in the long term. We can enable that for you. There, of course, is the installation services. And again, IBM is expert, of course, in their own product in delivering that. And, of course, in supporting you with your production rollout and your go-live process. Lastly, the delivery model is really a kind of iterative one. It uses your vanilla Scrum-based approach to delivery, which means, of course, that it should be familiar to people who are not necessarily governing ETL projects, but at least have an understanding of what agility and agile approaches to delivery are. So, of course, we start with the installation and configuration of Metal CI in your legacy environment and your target environment, if it's available, at least when it becomes available. Onboarding your DataStage projects and their assets to perform analysis and initial conversion work and highlight where there are known gaps or gaps that you didn't know about. And then, of course, we just iterate through the process of basically taking anything that's discovered as regressing in the target environment and treating that either in a just-in-time basis in the target environment or indeed in the upstream environment, the legacy environment, if in fact that is a change that can be made safely in both versions. And we've had customers, for instance, who've had assets that didn't compile, were discovered that just they didn't compile in the legacy environment, and they weren't expecting that. They wanted, in fact, to correct that and then feed that through. So again, these kinds of changes to give you something that is functionally complete, fit for purpose, and provable as such in the target environment, of course, are what we're going to iterate through until you're ready to go live. There's no differentiation for us between whether or not this is done in the cloud or on premises, or moves from on premises to cloud, or is some hybrid of the two. It really doesn't matter. The tools and the approach here are universal in that regard. Very quickly, there is an online estimation tool that allows you to look at the assets within your DataStage platform and to understand more about what that implies for upgrade. It will give you a level of insight, and it is the insight we use to optimize your upgrade experience. It'll give you a level of insight you've probably never had before. You can find that at the URL up there. And of course, that includes a lot more information about the offering. What I'm going to do is I'm going to hand across to my co-director, John, who is going to expand a little on that analysis, but also show you now the capability of the technology in action. And then after that, of course, we will cut across to your questions.
Thank you, Justin. Hi, everyone. Thanks for your time today. My name's John McKeever. We're going to quickly start by having a look at this rapid DataStage upgrade tool that we provide. And as Justin mentioned, we provide that cost-free. And rather than kind of show you any more slides, I'm actually going to take you into a real report which has been produced by a customer who uploaded, I think, multiple ISX files from multiple projects as a zip file. You can either upload a direct ISX or a zip of ISXs, and in anywhere between kind of 15 seconds and 3 minutes later, depending on the size of your upload, you'll receive an email with a link to a customized report like this. So this is giving me, on the front page here, an overall view of the complexity of my project. I can see in the top left, my jobs have been ranked by their complexity, and we'll look at that shortly. And we can see that 86% of my jobs have been ranked as very, very simple. So all of these tiny little 1% here, along this kind of flat part of the histogram, they are representing a disproportionate level of complexity in my project. And it might be something that we want to address as a priority. So below, I have a list of assets, in this case, DataStage parallel jobs, and they are ranked by descending complexity. So this top job here, with the highest level of complexity, would be this job over here on the right-hand side. And what we're really saying here is this job represents a complexity, risk, potentially an opportunity to refactor in order to reduce the mean overall complexity of your upgrade project. And the complexity has been calculated by us using a kind of proprietary approach, using a number of factors. We calculate something called the cyclomatic complexity of a job, which are the number of distinct pathways that data can take through the job graph. That's more than just counting links. It's a bit more sophisticated than that. We also look at the variety of stages and the complexity of stages you're using in your jobs. If you've got a source database stage and a target sequential file and a copy stage between, that's going to be less complex than a job that has Kafka and MQ series and Hive and the more complex stages that represent greater complexity. So we rank all of the stages by what we consider to be complexity and give this stage type ranking. We also look into, at the byte level, each transformer that's in your job and we look at the number of derivations and stage variables and the complexity of those. And we come up with transformer lines of code. So this particular job, for example, has 3,720 lines of code in its transformers. So that's a pretty complex job. Over on the right-hand side here, we have possibly one of the most interesting things on this page, the compliance failures. So our tool, MetalCI, ships with a library of currently approximately 50 coding best practices. So they represent what we consider to be good coding practices, coding anti-patterns. And in particular, we highlight coding anti-patterns that could be an obstacle to the portability or the testability of your legacy jobs. And we test all of the uploaded jobs against those compliance rules. If we take this most complex job here, I can see that we've looked for adjacent transformers. We have, in previous projects, identified that two transformers adjacent to one another represent an optimization opportunity. We've got default naming, where we've just got stages where it hasn't been given a name and may indicate a lack of attention, or possibly that the job that features those names isn't perhaps not a candidate for production. We can see that this job suffers from a compliance failure, too many stages. And this job has 65 stages, which we consider to be large. All of these compliance rules we provide as source code, and that they are fully configurable. And if we get time at the end, we'll go and maybe have a look at a couple of them. Unique sorts, which we feel are better represented as remove duplicate stages, and various others further down. You can also have a look at the different dimensions of your project. So here are the assets and the asset types and the count of each. You can have a look across your entire upload, which could represent one or more projects. You can have a look at the stage types, and you can say, okay, what's the most and least common used stage across my entire project? And if I want to say, okay, across my 3,200 jobs, I've got one modified stage, and that's the job that uses it. Or unusually, across all of those jobs, thousands of jobs, 2 jobs are using an Oracle connector, and it's only those 2. So they might be a place that you could start maybe investigating to look for unusual patterns in your implementation. Maybe that means something for your upgrade. And if we look at issues, we take those compliance rules again. Here are the compliance rules, a selection of the compliance rules that have been applied to this upload, and the number of jobs which have failed each of those compliance rules. So here I can see that we have a rule that says one data flow. So that's a coding best practice that says that each DataStage job should have one directed graph within it, not multiple graphs. We feel that should be better represented as individual jobs, and the 16 jobs that break that rule are listed there. So that might be something that we want to feed into our work backlog for the upgrade. And finally, we take all of this intelligence about your uploaded solution and we pump it into this calculator that enables you to adjust a few parameters and work out, get an overall view as to how many iterations are going to be required to upgrade your uploaded project. I don't want to go into this too much, because what I want you to do is to go to the website, rapiddatastageupgrade.com, and upload your own project and have a look at something more relevant to your use case. So we're going to start by having a look at a tool called Atlassian Jira. Licenses for Jira are included with a Rapid DataStage Upgrade subscription. And this backlog of work items that you see here, Jira is very similar to a lot of work item management systems. This backlog has been auto-generated by the tool you've just seen. And I've got a couple of tasks that I need to do. This is my avatar here. And one of them is to fix compliance for a job called TR Purchase. Now, some of the compliance rules we saw are, just kind of coding best practice. Some of them will be absolutely mandatory for us to be able to move a job from one platform to another. And which jobs are advisory and which ones are mandatory are up to you to decide as part of the engagement. So I'm going to go and fix compliance, so bring my job into alignment with our coding best practices in order to support the upgrade for this job TR purchase. So I'm going to go over to this environment here, which is a DataStage 9.1 environment. We support all the way back to 8. Certainly 5 earlier, I think. Yeah, probably I think 8x onwards. So no problems there, and right up to 11.7.1 that was released just a couple of weeks ago. So we're looking at this job TR purchase. I conveniently have it open, and I want to do 2 things with this job. I want to check that it meets our coding standards in order to address that story, and also I want to create, or I want to verify that I have an automated unit test that provides some evidence that this job will behave the same in our new target platform as it does on our existing 9.1 platform. So let's start with the unit testing, I think. So I'm going to go to the Tools menu in my DataStage Designer, the Custom menu item, and I'm going to go to Metal CI Unit Test Spec. That's going to take me into a browser-based interface for this tool, Metal CI. This is the Metal CI workbench. It's effectively a developer assistance tool that provides, as you may see on the left-hand side navigation, unit testing capabilities, the ability to check our job against compliance, and then also the ability to push our job into Git, which is the beginning of the delivery workflow into our target environment. The thing you're probably looking at in the middle of the screen here, all this text and interesting looking things, this is a unit test specification for our job TR purchase. I have the actual specification at the top, which is a YAML file. Don't need to worry about that. That's just a syntactic convention, and it's represented here in this text editor. Anyone who's done any Ruby programming may recognize the structure from Cucumber, which is a popular automated testing tool for Ruby. And it basically says, given these inputs, when the job is run with these particular parameters, then a successful unit test is when this output produces these values. And our inputs are expressed as the job input links, not just stages, but links, because remember, a source stage can have provide multiple input links. For each link, I'm giving us the name of a CSV file. And each of those CSV files are available over here on the left. So for this particular link here, EX purchase in purchase, I can have a look at that CSV file. And this is just like an Excel editor. I can go in here, I can change values, I can add columns, remove columns, copy and paste columns. If I want to, I can even, I'm just going to discard those changes. I can even create a new CSV test file, and I can use Metal CI's data fabrication capabilities. So let's say I want to create a bunch of first names of any gender. I'll do that. And let's say I want to create some a suffix, sorry. I'm going to create a street address, and it's going to be a full address, and I'll call the column address. There we are. In fact, I'll rename this column name. And let's say I want a few more rows of test data. And there we go. We've got a very quick way of fabricating some realistic looking test data that avoids propagating any PII, personally identifiable information out of an environment where it shouldn't be. So that's pretty handy. I'm just going to get rid of that. The fabrication algorithms we provide, I think we provide something like 200, don't quote me on that, ish, fabrication algorithms to cover a broad variety of data fabrication requirements. Now, everything you're looking at here, both the specification that identifies all of our sources and targets, and each of these CSV files, not the content, but certainly the file structure, with the data types. This has all been created automatically on the initial onboarding of your DataStage project into Metal. So the first step with Metal is to scan your project, read each job, and identify source and target stages, and create those files. So metadata capture, identifying source and target, creating those CSV files. What you can also do, as well as using the data fabrication I just showed you to create test data, I'm sure you've already got existing test data. You've got existing data sets, existing test databases. It would be really great if you could snapshot that and load it into Metal to create a portable automated unit test. And that's what you can do with our test data interception. You can run your DataStage job in a special mode, and we'll come on to having a look at that in a second, where Metal CI will intercept at runtime the execution of your job and will inject a component which sniffs data flowing down those input and output links and captures that data into those CSV files. So if you've got those existing data sets and databases, they can become CSV files. And the important part of capturing them into Metal is that those CSV files will get checked, and the specification will get checked into Git alongside the job and pushed into your target environment, where they will be automatically executed. So we can say, I have an automated unit test that runs on my legacy platform and goes green, and the same test runs on my target platform and goes green there. And hopefully we'll see that shortly. The actual process of running a unit test involves a similar kind of interception technology. At runtime, you invoke your job in a special mode, a unit testing mode. Metal CI will identify the source and target stages, replace those at runtime with its own components, inject the contents of those CSV files. Similarly, for the output, we'll replace our own component, read what's appearing at the outputs, and compare it to the CSV file that we define as being the acceptable output. And that's a test. So plenty of talking. Let's actually see something in action. Right, so here we go, back to DataStage. I'm going to run that unit test that you just saw. So I'm going to do that from Designer, just running as normal. I'm going to set some of my regular old parameters to make my job work, but I'm going to use this special parameter, punitTesting parameter, and I'm going to set it to enabled. What that actually does behind the scenes is set an environment variable. So if you wanted to configure an entire project to run in unit testing by default, that's possible. Maybe not advisable, but I just wanted to let you know how flexible that is. And if you want to, you can also ask Metal CI to add this parameter to your jobs in order to unit test enable your project. So I've simply set this value to enabled, and I run my job as normal. Designer works as normal, logging works as normal. We've got a warning here to tell us that we are in unit testing mode. So these source databases at the top will not be accessed. This source data set will not be read. We are injecting at runtime our own components, and you can see from the link counts, these are the number of rows being injected by from our CSV files. And we can see a warning here that the unit test has failed. So if we go to the Tools menu, Custom, and the unit test result, that takes us back into our interface where we can in fact see that our unit test has failed, and we get a diff style view. We've got the right number of rows, but different values in columns. The order quantity is way off. We've got expected versus actual, and also the last modified when column is off as well. So let's go and start by having a look at that order quantity column. You may be shocked to learn that I know what that problem is because I created it for the demo, and it's this expression in a stage variable here. Someone's tried to add Australian 10% sales tax to that value. I'll get rid of that and I'll OK that. So I think I've probably addressed this particular functional error in our unit test. I've still got this last modified when column with an incorrect value in. And interestingly, we can see that what's been injected in there is today's date, 21/28, which, believe it or not, is our local time in our time zone now. So I'm going to see if I can use any more evidence to understand what's going on with that column. So what I'm going to do is I'm going to go to the custom menu item, and I'm going to compare our job to our library of coding anti-patterns, those compliance rules that I mentioned earlier. Again, brings us into the metal interface. It's already got context, and I simply hit run compliance. We can have a look at the logs. What that's doing now is it's exporting our job from the development environment. It's loading it into in-memory graph database, comparing it to 50 rules, of which 28 currently apply to parallel jobs. And we can see that I've got 5 failures. So here are a list of all our rules which are currently being, which our job is being tested against. And if I just filter down to the 5 failures, let's have a look at them in detail. The first one is hard-coded file paths. That's important for upgrades and for portability of jobs between environments. I've got a reference to the file system, which is absolutely dependent on the new target platform's file system looking exactly like my legacy file system. And that's not good, because we may not want to structure the target file system exactly the same. And it also impedes testing as well. So it's telling me that DSEX purchase of type dataset has a hard-coded path. It's even giving me a bit more information and saying that for this particular rule, our organization has decided that datasets should all live in the directory pointed to by this parameter. So let's go and fix that. I'm going to go into that dataset, and we can indeed see that I've got a hard-coded file path. So let's get rid of that and insert the appropriate job parameter. There it is. Good. I think I've fixed that particular compliance rule. The next compliance rule is a failure, and I don't need to worry about this. This is actually a warning, and I know that it's not going to stop us delivering a job into a target environment. This is telling me that a particular stage, ODBC supplier, is not compatible with ICP for data, IBM Cloud Private for data. That may be something you're interested in. There's also a rule in there that tells you which jobs or elements of your jobs are not compatible with the new DataStage Flow Designer, the web-based designer. So I can just treat that as informational. I don't need to do anything. I don't need to action that at all. The next error, deprecated stages. This, I happen to know that Metal CI will handle this by itself. As we push the job through the delivery pipeline, it's going to perform the CC migration. It's going to invoke the CC migration tool automatically, so I don't need to worry about deprecated stages being upgraded. That's handled for me. The next error is interesting, system time dependency. TR purchase ordered depends on system time. I wonder if that's related to my unit testing error. So let's go and have a look at that particular stage. TR purchase ordered, and we can in fact see that we're calling the current timestamp. The reason that's a problem is it impedes, excuse me, it impedes testability. If we're calling the system clock as part of our DataStage job, it means that our job is going to produce a different result depending on the time and date that I run it, which is great, and it may be what you want, but it impedes testability. What's better is if you use a parameter there and you provide the system clock information at invocation time. That way we can always provide a static date for testing and get reliable testing results. What I actually know should be going on here is we should be mapping that column there. So that's good. And I think we've just got one more compliance error left. Yes, stage naming, stage TR purchase ordered, the one we were just in, of type transformer, has an incorrectly formatted name and should be TX. This isn't a big deal. Good stage naming assists information governance catalog in determining lineage, but it just takes 2 seconds, so we may as well just fix that. So I think I'm just going to compile that. I think I've got a job now that meets our unit testing functional requirements and is compliant. So I'm just going to quickly run a unit test again. I'm going to enable. I'm going to just provide my parameters, and that should be very quick. And in fact, if I just go back to my unit testing result, oh, here we are, it updated live. It's very quick. So that's now successful. And we can see that we've finished with no errors. And because it's quick as well, I'll just do a quick compliance run as well. Quick compliance, there's our context run. That should just take a few seconds to export the job, compare it to our library of rules in memory graph. There we go. 2 rules failed, which are the ones I expected. So that's good. I've got a job which is a candidate for pushing downstream into our target environment. Before I do that, I'm actually going to, Justin, give me a code word that we can identify this as our job.
Let's say VCD for Virtual Community Day.
Beautiful. Virtual Community Day. Okay, so so we know that when we see a job in the target, it's the one I've just changed. And Justin didn't fake that. In fact, I'm going to prove it. I'm just going to jump into our 11.5 environment where our job has already been pushed, and it's the old one that I did this afternoon just as a pre-flight check. So this is our 11.5. I'm going to go back to 9.1. This is our job, which is a candidate for upgrade. So I'm going to go to the final menu, Custom Metal CI, check in Asset. This is going to take our job and commit it to Git. It already has our asset listed. I could add other assets if I wanted to as part of the same commit, but I won't. I like doing one job at a time, so my commit message can be very specific. I'm going to include my unit test artifacts. I haven't actually changed them, but I always like to do that as a habit. So if I had added any more rows to my unit testing files, then those updated files will get taken along with the job as well. I'm going to look up my job in my work item management system, Jira. I'm going to, try and type correctly. And I'm going to link my commit to my work. If I go back to Jira, it was 246. Is that the right one? 246, fixed compliance for TR purchase. And I'm going to say, hello VCD people. Okay, that's our commit. And I'm going to hit check-in. And that's the last thing I need to do before my job should appear in the target environment. Obviously, there are a number of steps that need to take place before that happens. So what's happening behind the scenes? We've got a green success there. So I should be able to see in our Git repository that that job has been committed. So I'm just going to jump into Git. Here is Atlassian Bitbucket, which is just a veneer over a vanilla Git. We support any flavor of Git, but again, a license for Bitbucket comes along with your subscription to this offering. Here's the structure of our repository, and I'm just going to quickly have a look at the commit history. And there at the top is our commit. Because we're using Atlassian Jira and Atlassian Bitbucket, if I go back to my Jira story, 246, you may have seen that it automatically updated when it received the focus. Here, our commit message has also become a comment against the business requirement, and the commit history for this story has been updated with a reference to our commit. And the file that's been committed is trpurchase.isx. So that's good. What that has also done behind the scenes, if I just go back to Bitbucket, we can see that there's a build occurring, one build in progress. So what's happening is this code is being taken and deployed into an environment where it will be compiled and tested for compliance and unit testing. The final Atlassian tool we're going to jump into is, I'm just going to show you this. This is Atlassian Bamboo, which is an equivalent of, say, something like Jenkins, if you're more familiar with that as a CI/CD tool. Here are a number of activities that our automated build system can perform for us. And you can perhaps detect with this spinning icon here that we're currently undergoing continuous integration. Just click on that, and what that will show us what's actually going on behind the scenes is that we've deployed that code. We're currently running our different flavors of compliance rules. That's done. And now we're running those unit tests. So this is all happening on 9.1. What we're doing is we're saying, before I push those artifacts into an 11.5 environment, in this case, do they compile? Are they compliant? Does the unit test work? Is this a good candidate for deployment? We've gone green, so we know that this is good. What that has now invoked is something on this screen here, and there we go. The upgrade demo here, we're now deploying to the 11.5 environment. We're also deploying to a 9.1 testing environment because, of course, day-to-day life carries on in 9.1. We're not just migrating at a point in time, as Justin mentioned. The point of this offering is that we can absorb day-to-day change and support your existing software delivery practices. So we're currently deploying both into a 9.1 and an 11.5 environment. Lots and lots of things going on, lots of things to keep track of. One of the tools we also provide as part of this offering is this. This is called the Metal CI Wallboard. It's a fully configurable JavaScript dashboard, JavaScript-based dashboard. We've got our sprint health at the top, a number of stories allocated to each developer underneath that. We've got some performance information coming live off Operations Console for both legacy and target environments. We've got the status of legacy and target engines. In the top right, we've got information from our build system about the build activity that's going on, i.e. the number of build agents which are doing things for us. And on the left-hand side, probably most interesting, we've got a map of our environments in the bottom left. You can see that 9.1 has been upgraded to release 188, and 11.5 is in the process of being upgraded to release 188. And in fact, at top left, we can see that the deployment to 11.5 is currently in progress. And if I just jump back to deployments, yeah, we can see that that's still happening. What will happen as soon as that deployment has completed is we will then execute a final piece of build activity, which I'll just jump back, which will be to perform the in-place upgrade of those jobs. You may be noticing some notifications coming up in the bottom right of my screen. What we've also got configured here is for this build activity to be stitched into our instant messenger. In this case, we're using Slack. And if I go to my Slack channel for the demo, I can see that I'm receiving live messages to tell me that for that recent Git check-in, that continuous integration, we've got some failures there, but we know that they're not important failures. They weren't classified as failures that stop CI, but the CI has actually passed. CI 128 has passed, and we can see that release 188 has been successfully deployed to the version 11.5 platform. And if I go back, we can see that the final process is occurring, which is where Metal CI is going and inspecting what's been deployed into 11.5 and identifying where activities need to occur, particularly the CC migration, so the automated uplift of jobs into the compatibility with the new DataStage platform. We also do other smart things there as well, like if you're redeploying a shared container, we will find all of the jobs that use that shared container and recompile them as well, because that's not something that Information Server does automatically. So you can be sure that what's in your 11.5 environment is in alignment with your compliance rules, has evidence of successful unit testing, insofar as your unit test data will illustrate that, and that there's no internal consistency between, say, shared containers and the jobs that use them. So if we just go back to our wallboard, we can see that that upgrade deployment is completed. Have we got any questions on chat? Are you able to see those, Justin?
Yeah, so far, just while we wait for that to finish, there is one question around the use of the compliance tool outside of the context that we're talking about it in terms of the upgrade, and whether or not it could be presented just as an API for people to integrate into their existing quality assurance processes and whatever other automation they may have built themselves. Certainly that is possible. If you're interested in that, please go to metalci.com and submit an inquiry there so that we can follow that up with you.
Or come back to this track in 8.5 hours time. Yeah,
if you're around at the end of the Virtual Community Day around 4 p.m. US Eastern Time, then there is further discussion of how compliance works. But for the purposes of the rapid data stage upgrade, it's essentially a kind of black box process that supports the upgrade team both the IBM consultants and, of course, the customers team as well, to accelerate through understanding where the issues are that will need to be treated in order to make the upgrade work fine.
One thing I might just highlight in the gap is you do not have to perform this activity for every job. The starting point for this, for what you've seen today, is a bulk ingestion of your legacy platform into Metal and the bulk deployment of that to a new target platform. The only time you need to get involved is for the support for creating unit test data, and where compliance rules highlight something that's absolutely mandatory for you to address as a human that can't be automated. And what we're actually seeing right now is we've deployed to 11.5, we've performed CC migration, we've identified anything else that Metal CI needs to do, and finally, we're running those same unit tests which have been pushed over into the target environment in order to verify that we've got success. There's our job completed, there's our Slack message, and I guess I have to do the proof by going over to our 11.5 environment, opening up TR purchase. Oh, possibly. Refresh. And there's our job. And one thing that's worth noting, if I just go back to our, that's not what you want to see. If I just go back there, if we look at these legacy ODBC stages, it's exactly the same job, except they've been upgraded to new ODBC connectors. But other than that, identical. More questions?
So at the moment, we haven't got any more questions in the chat. Just remember, again, we can't hear you. So if you do have questions, please put them in the chat window, and then we'll be able to see them while we're waiting for any other questions that people may have. We know, of course, that in the US, this is pretty early in the morning. So, so maybe we're going to get more questions from places such as Europe or India and so on. We'll just summarize. What we've done here is shown you, I guess, a point in time, a kind of exercise that you would expect to happen some way through the upgrade process. So again, we would have done our initial onboarding of all of the baseline golden copy of all the projects in your legacy environment. We would have already produced that backlog that you could see John showed you in Jira. And really now we've just shown you working through one of the issues that backlog was thrown up, and showing you how that really, as long as you, when you make a change in the legacy environment, you check that change in, then Metal CI takes care of the rest. And so, of course, this is what in the upgrade scenario is going to be largely done by members of the IBM team who are going to be working with you, or in fact maybe a combination effort between yourselves as customers and the IBM crew as well. And again, there's the flexibility to do that within the offering. Mainly, the important thing is that the total cost of doing this work and having at the end of it a granular, auditable, traceable history of all actions taken against every single asset that moved from your old environment to the target environment, the cost of doing that and the reliability of doing that is entirely shrunk by the use of Metal CI, and of course, you know, the fact that the IBM crew know Metal CI and are going to be operating it or supporting you in operating it, depending on the phase of the project, to optimize the end-to-end throughput. So we'll look again. I don't know if we have any other questions. Okay. Well, if there's nothing further on that front, we'll just summarize perhaps. The offering is an IBM offering. It's an IBM Data and AI Labs offering that is using Data Migrator's Metal CI technology. You can inquire either via the Rapid DataStage upgrade.com site, or you can go to your IBM rep, your IBM UG&I or Data and AI representative, and ask him or her to investigate the availability of the offering in your particular region. They have access internally to their own wikis and so on that allow them to learn more and obviously to respond to your inquiry. Also, we have the people who are online here All of our email addresses are in the slides that you can download at the end of this session. They also can respond to individual inquiries. So we're easy to find one way or another. Please do reach out, make contact with us, and we look forward to supporting you in a successful upgrade for your platform to a contemporary version of Information Server and opening up all of the possibilities that those new platforms give to you.
And please do come back and find out more about the use of this technology in a BAU DevOps context in 6 hours.
Something like
8
that.
hours. 8 hours.
Yeah. Okay, thanks again. So this is Justin McCamish, John McKeever from Data Migrators, and of course Elvis Gomber from IBM Worldwide signing off. Thanks again for your time, and looking forward to working with you.
Enjoy the community day, everyone. Thanks.